Welcome to the first in a series of instructional short webinars from Xigo Nanotools, where we will describe the range of instruments we have for particle characterization and how to use them, and the applications where we feel they would be suitable. Our agenda in this first talk, which is described as exploring surfaces with the Acorn area, we'll cover why should we use nuclear magnetic resonance? What are the practical advantages? Why it is important to work with concentrates and the consequences of dilution? How does NMR work? The relaxation method and its technique, and the utility of the measurement itself. And finally, we'll look at the Acorn area specific instruments, the instrument itself, and the various options that we have. So first of all, why characterize suspensions using nuclear magnetic relaxation? Well, most particles are made or used as suspensions in liquids. Most suspensions are actual concentrates. And the particle-liquid interface, no matter what the particle, no matter what the liquid, that interface controls product performance. And by product performance, what we mean is what that suspension is designed to do. A nuclear magnetic resonance relaxation is uniquely sensitive to two very important features of the particle-liquid interface. First is the extent of the wetted particle surface, and in here we can include size, shape, morphology, and indeed porosity. It's also sensitive to the chemical nature of the particle surface, the surface charge, the type of functional groups on the surface, because this affects the wetting itself. And the nature of the particle surface, no matter what you have, affects how liquid actually interacts with that surface to give you the suspension that you want. So as we can see here on the little diagram, the nuclear magnetic resonance results cover two aspects of interfacial science. One is the extent of surface, and one is the surface chemistry. And the technique of nuclear magnetic resonance is unique in this, because typically you find instruments traditionally which will measure the extent of surface, such as surface area measurements and particle size. Or on the other hand, you can have instruments that measure surface chemistry, such as zeta potential, but they can't give you information about both.